In this video, I'm going to go through some tricky questions from exercise 1D. Well, I'm not going to go through them completely. I'm just going to give you some hints as to how to approach the more tricky parts. So I think the first question you might get stuck on is question 4. In the part where it asks you to show that 32 cos squared theta multiplied by sine to the power of 4 theta is equal to is cos 6 theta minus 2 cos 4 theta plus 2. So I think you might get stuck on what to do with the left hand side, bearing in mind we want to apply de Moivre's theorem. So I think the nice thing here is that you can express it in terms of one function only. So replace your cos squared with 1 minus sine squared theta. So this is your left hand side, multiplied by sine to the power of 4 theta, and then you've got 32 sine to the power of 4 theta minus 32 sine to the power of 6 theta, and treat both of those terms separately. Use de Moivre's to replace them with causes and then combine them together. Next question, I believe you might benefit from going through, is question 6. So it says in part A to use de Moivre's theorem to show that cos 6 theta, express it in terms of powers of cos, and then it says hence or otherwise find the solutions to a given equation. So let's just write down in part A. I'm not going to go through how to do it because you should know it, standard question. So let's just write down this identity. So you're going to use this identity to solve the equation in part B, which is 32x to the power of 6 minus 48x to the power of 4 plus 18x squared minus 3 over 2 equals 0. So the thing is just to glance at the identity above and have a look at what is the same here. So if you look very carefully, you've got 32 cos to the power of 6, and you've got 32x to the power of 6. Then you've got minus 48 cos to the power of 4 theta, and you've got minus 48x to the power of 4. Then you've got plus 18 cos squared and plus 18x squared. Now here you've got minus 1, and here you've got minus 3 over 2. But minus 3 over 2 is minus 1 minus a half. So you actually do have minus 1. Just you've got this minus a half that's left over. So what you can do here, that should make you realize that you can actually use x equals cos theta replacement to write this in terms of cos 6 theta, because if I replace the bits, if I do it in pink over here, 32x to the power of 6 minus 48 x to the power of 4 plus 18x squared minus 1. If I replace each x with cos theta, I am going to get cos 6 theta. I still got that minus a half left over, so you're going to now solve cos 6 theta is equal to a half. Then you're going to find we are looking for solving something to the power of 6. You're looking for 6 distinct solutions, unless, they've asked you for 6 distinct solutions, because any polynomial of degree 6 can have up to 6 real solutions. So let's solve that. 6 theta is equal to pi over 3. Then you've got 2 pi minus pi over 3, so 5 pi over 3. Then you're going to add 2 pi, so you're going to get 7 pi over 3. Let's add 2 pi again, so it's 11 pi over 3. I'm going to carry on till I get all 6 solutions. So let's add another 2 pi, so it's 13 pi over 3, and another 2 pi, so that's going to give me 11 add 6, which is 17 pi over 3. Now finally you're going to get theta is equal to pi over 18, 5 pi over 18, 7 pi over 18, 11 pi over 18, 13 pi over 18, and 17 pi over 18. Now the mistake would be to leave these as your solutions. These are only the thetas that you will obtain by solving this equation. But bearing in mind that x is cos theta, all we need to do is substitute these into those and you will get your x's. So x is equal to cos pi over 18 is my first solution, and I'm just going to do the first one here. So it's cos, turned it off, cos pi over 18. So that's 0.9848, so 0.985. If you put the other values into cos, you'll get the other solution. So this is one of the solutions. So this is your job to finish this question off. So another question from this section that I'll just quickly address on question 7. Don't believe either part A would cause you a problem or part B. Although part B, we better go over it. Right, so in part A, you had to show that the following is true. So I'm not going to do that, you can just do it yourself. Cos cube theta sine theta minus 4 cos theta sine cube theta. And then it asks you for part B to find the expression. So we want the expression for tan 4 theta. So really tan 4 theta is sine 4 theta over cos 4 theta. So what you really need to do is, once you've shown that sine 4 theta has this expansion, let's find what cos 4 theta is using the Moivre's theorem, using really what you've done in part A. You could just read it off. So if I just give you the answer to that, you need to do it yourself. Minus 32 sine to the power of... No, that's the wrong one. I do apologize. I was copying it from the different... There you go. It's 4 cos cubed sine theta minus 4, forgot theta, cos theta sine cube theta. So what we're going to do, we're going to substitute these expansions into this fraction. So 4 cos theta sine theta, take away 4 cos theta sine cube theta, goes on the top, and on the bottom of the fraction is 4 cos cube theta sine theta. Oh, that's the same one. Okay, let me just check. Okay, I accidentally copied the same expression for both sine and cos, so I've read it off again. Obviously you will have to do it fully yourself. Cos to the power 4 theta minus 6 cos squared theta sine squared theta plus sine to the power 4 theta. Right, so the trick here is to have it written in terms of tan. So the idea is, look what you are aiming for. The expression in part B, they give you actually your target answer. They say you've got 4 tan theta on the top of the fraction minus 4 tan cubed theta and then on the bottom of the fraction 1 minus 6 tan squared theta plus tan to the power 4 theta. So what I like to do is have a look what I'm aiming for, and I realize here that I want to have 1 as the first entry of the denominator. So at the moment I've got cos to the power 4. So really what I need to get rid of it. So you get rid of it by dividing by cos to the power 4 theta. But whatever you do to the bottom of the fraction, you must do it to the top of the fraction. So every term, and you've got 2 terms on the top and 3 terms on the bottom, need to be divided by cos to the power 4 theta. So let's just write it long way. You've got 4 cos cubed theta sine theta, that's got to be divided by cos to the power 4 theta. Then you've got 4 cos theta sine cubed theta, that also has to be divided by cos to the power 4 theta. Then you've got cos to the power 4 theta divided by cos to the power 4 theta. Then minus 6 cos squared theta sine squared theta, that also gets cos to the power 4 theta. It's a bit tedious to write it all out, but I don't take any shortcuts, but just write this line in. Okay, so now you just need to cancel the common factors. So cos cube here will go. You've got cos theta left, you've got sine cube, and you've got cos theta. Oh dear, cos, you will have cos cubed left. That cancels, so you've got 1 left. You've got cos squared, so 2, and this one can't cancel. But what you should have left, what we should have left is this, because do I have 4 tan theta? I do. Do I have 4 tan cubed? Well, it didn't initially, I made a mistake, but yes, sine cubed over cos cubed, etc, etc. So you can finish it off. Okay, and finally the question part C is really very similar to question 6. We are solving x to the power 4 plus 4x cubed minus 6x squared minus 4x plus 1. So what we want to do is equals 0. What has this got to do with our identity for tan 4 theta? So if you look at the right hand side, if you think about doing a similar trick to what we did in question 6, if you were to replace these with x's, you will have 4x minus 4x cubed. So if you let x is equal to tan theta, and 1 minus 6x squared plus x to the power 4, and that's what tan 4 theta is. So how can I obtain this fraction from this equation? So to solve this equation means you've got to solve 4x, if I move that 4x across, minus 4x cubed equals x to the power 4, leave it on there, minus 6x squared plus x to the power of 4. All right, 1. Do it in the same order as they've done it, like this. Okay, and then you just need to divide. So if I divide this side by this bracket, I'll have 1 is equal to 4x minus 4x cubed over 1 minus 6x squared plus x 4. So all I need to now focus on is on solving this equation. You find the solutions. We are looking for, should be 4 solutions because you are solving polynomial of degree 4. Find thetas. You will have 4 of these, 1, 2, 3, 4, whatever they are. And then you are going to substitute them into this substitution to get the answer. There you go.